Hello everyone. So now we will study the concept of CMOS inverter. So many people who prepare for analog domain specifically, they ignore this topic and say that it is asked in digital interview only. But no, even for the analog inputs, you can analyze this circuit, right? It is basically a circuitry, and it has also a high gain. We will see the gain of it. So it has also a high gain. So this is used in analog industry. Okay. So CMOS inverter is important topic. Okay. So now first we will see what is a buffer and what is an inverter. So what is the main difference between those two? So basic difference we will see. Let us assume this is a buffer. Okay. This is how we make a buffer. So this is how we make a buffer. So in case of buffer, if you give a high input, you will get a high output. Okay. And in case of buffer, if you give a low input, you will get a low output. This is what a buffer is. Okay. I'm talking about a inverter. So this is how you make an inverter. Okay. Yeah, so in case of inverter, if we give high output, we get if we give high input, we get low output, and if we give low input, we get high output. This is the case of inverter. Okay. So now we will see CMOS inverter. So first we will analyze the CMOS inverter for pulse input. Okay. So what is the circuitry of CMOS inverter? That we will see. This is the PMOS, and then in series with the NMOS. Okay. So this is the circuitry, and both have a common input. Okay. Both have a common input Vin, and this is VDD. From drain of NMOS and from drain of PMOS we get the output. Okay. So this is the circuitry of CMOS inverter. And what will happen if we interchange the PMOS and NMOS? It will become a buffer. I will upload that video. Okay, no problem. I will upload that video. If we interchange it, what will happen? That we will upload. Okay. Now the input is pulse, right? So we will make a pulse input. Okay. So like this is time 0, this is t by 2, this is t, this is 3t by 2, this is 2t. And one thing is that t is very large. That would be given. Okay, t is very large. And one input what we can put is 0 volt. One input we can put is 0 volt, and one we can put is VDD. Okay. So we will analyze it now. So for analyzing, I will use. So for 0 to t by 2, 4 times 0 to t by 2, what is your Vin? Vin is equals to 0. Then V, in case of PMOS, if you see, your VSG would be VDD, right? And in case of output, we can connect a capacitor. Okay, here in the output we have some load, that is a capacitor. Okay, so that we have connected. So what is VSG? VSG is VDD, and what is your VSD? That is equals to VDD as well, because your drain is at 0 potential. VSD is at VDD only initially at t equals to 0. At t equals to 0. Okay. So here this VSG is greater than VTP, right? VDD, like the value is not given, but you can take Okay, let VDD equals to 5 volt, VTN equals to mode of VTP equals to 1 volt. Okay, so VSG is greater than mode of VTP. That means it is on and in saturation region. Why in saturation region? Because VSD is greater than VDD minus VTP. Right? VSD is greater than VSG minus VT. Then it is on and in saturation. And in case of NMOS, at t equals to 0, in case of NMOS at t equals to 0, VGS would be 0 only. That means it is off. So your PMOS is on and your NMOS is on. So NMOS is off. So for 0 to t by 2, your PMOS is on and your NMOS is off. So if you draw the characteristics, now what we can write is initially PMOS is in saturation region. Okay, so what happens is that PMOS can be replaced with current source, right? PMOS can be replaced with the current source, and NMOS will be open circuited. This will be open circuited. So now what is the situation is that whenever a device is on, whenever a MOSFET is on and it is in saturation region, it will be replaced with the current source. And whenever it is in a linear region, it will be replaced with the R own resistance, right? R resistance, right? We know that, right? R own resistance. Okay. So now this is replaced with the current source, and at output we have this capacitor C, right? This is V naught, this is the capacitor C, and this is open circuited, right? This is PMOS and this is your NMOS, right? And this is VDD. Now whatever the value of this current source is, that will charge this capacitor, and the capacitor will start charging. The capacitor will start charging linearly. Okay, so the capacitor will start charging linearly. Initially it will charge linearly. Okay, so this is your V naught versus time t curve. Now it will charge, it will charge. Now at one point V naught will reach 1 volt, right? And this is 5 volt. In this case your VSG is fixed. Your VSG is fixed at 5 volt, right? Your VSG is fixed at 5 volt and your V overdrive is VSG minus VT, it means 4 volt. Now your V naught is getting up. That means your VSD is getting low. If your V naught is getting up, your VSD is getting low. When V naught equals to 1 volt, when V naught equals to VT, or when V naught equals to 1 volt, your VSD would be equals to 4 volt, right? Your VSD would be equals to 4 volt. So after that, it will go into the saturation region. Now V naught is increasing. That means your VSD is decreasing, but V overdrive equals to VSG minus VT P, that is equals to 4 volt, is fixed. That means, and PMOS is moving towards what? Moving towards linear region, right? Linear region. Okay, your V naught is increasing, that means your VSD is decreasing, that means your V overdrive is fixed, that means if it is moving towards the linear region. Okay, so it is moving towards the linear region. So when we, so at point of no, at VSD equals to VSG minus mode of VTP. Okay. So what is your VSD? VSD is VDD minus V naught. Your VSG minus VT is 4 volt. So VDD is 5 volt. So V naught would be equals to 1 volt. Okay. So when V naught is greater than 1 volt, at that time your VSD is less than VSG minus VTP. That means at that time linear region. We are moving towards the linear region. And if we are moving towards the linear region, that means PMOS will be replaced with R ohm, right? So this will be replaced with some R ohm value, and this is VDD, and no comments about PMOS NMOS because it is still off, right? So this is V naught and this is like this, right? Here I can write NMOS is still off. NMOS is still off. Okay. So now it will charge exponentially. So exponential charging is there. Okay. So instead of making this curve here, I should have made it on next page, but forget that, we have written the explanation. So after this it will charge exponentially. So I can make it look like this. And till what voltage it will charge? It will charge till VDD voltage, right? So from 0 to VDD it will charge. And this is what is we don't know the value of time, but we know that this is the value VT, right? When V naught is equals to VT over 1 volt, here we have seen. After that we are going into the linear region. So this is the linear region and this was the saturation region, right? So you understood this. But in many of the book or in many, even in the interview, if you say that the PMOS is on, so it will be replaced with the resistance, so we will see exponential charging of capacitor. So even that would be that they will also consider. If we see deeply, we see that initially it is linearly charged. After that, it is exponentially charged. Okay. So, but in the interview, they don't notice this much. If you say that it is charged exponentially, then they also consider it. So this is what is happening. For a very small region, it is in saturation region. Then it goes to linear region. Now for what? For T by 2 to time T. Your V in is 5 volt, right? For T by 2 to time T. Your V in is VDD, that means V in is 5 volt. So now for PMOS, your VSG is 0 volt. That means it is off, right? So PMOS is off. And for NMOS, what is your VGS? That would be 5 volt. What is your V overdrive? V overdrive is 4 volts VSG man. And what is your VDD? ds, that is equals to v naught. Okay, and currently at t equals to 0, at t equals to 0, your vds is v naught, that is equals to 5 volt, right? Because it has been charged till 5 volt. It has been charged till 5 volt, right? So at t equals to 0, at t equals to 0, vds is 5 volt. So at t equals to 0, your vds is greater than v overdrive. That means it goes to saturation region. Okay, so NMOS will be replaced with current source, right? So your NMOS will be replaced with the current source. So this is the PMOS, that is open circuited. This was VDD. Okay, now this is the capacitor there. Okay, this is V node and this is the current source, right? This was already charged to VDD, that means 5 volt. Now the current is flowing in this direction. So this discharges the capacitor linearly. That means your V naught goes down. Okay, so your V naught goes down. So that means VDS for NMOS goes down. If it is goes down, that means NMOS is moving towards what? Linear region. That means when VSD is less than V overdrive. So what is VSD? That is V naught. That is less than 4 volts. Then we will move to linear region, right? So how will the output look like? What I can do is that I can simply copy this one and I will paste it here. So first what is happening is that it is linearly coming down, right? So from 5 to, from VD to from VDD to, it comes down to VDD minus VT, right? VDD minus VT, and then if it has moved to linear region, then NMOS will be replaced with R own, right? So there will be exponential discharging. This is charged to 4 volt. This is replaced with R on. Okay, and this is open circuited, and this is VDD. Okay, so this will get discharged. From 4 to 0 we will go, but exponentially this time. So this is how it goes to 0 volt. And now the same cycle goes on. Okay. This is time t. Then again the same cycle repeats. again charges, then linear, uh, then this is in the saturation, and then it comes to the linear region. Okay, so this same cycle goes on. So from this to this, we have, this is the saturation region and this is the linear region. Okay, so this is the complete analysis. But in the interview, if you say it gets exponentially charged and it will get exponentially discharged, then they can somehow consider it. But if you tell this, first it will be in saturation, then it goes to linear region, then it comes down. So this is the exact analysis and this is the correct analysis. Okay, so now you have understood this concept, and there can be few more questions. Okay, so what they can do is that I will add on these question, those question. So what they can do is that they will make the same CMOS inverter. This is V in, VDD. This is also V in. Okay, I am just making it separately, nothing else. This is your V out. This is grounded. Now what I have done is that I have connected one more NMOS in parallel. Okay, you know what does this sign mean, right? I have told in one of the video, I guess. Okay, what does this sign mean? The same potential V, this sign really means like this. Okay, the same potential V in is applied there, so we can make it like this as well. To make the circuit look less complex, we make it like this. So this V in is applied here as well. Okay, so this is what it means. And now this is the capacitor C. So now you need to comment on capacitor charging and discharging. On capacitor speed of charging and discharging. So tell me the speed of charging and discharging, how it will change. First we talk about the speed of charging. When the capacitor is charging, that means your PMOS is on. Your PMOS is on. So there is only one PMOS. So there is no change in the speed of charging. Speed of charging remains the same. Now coming to the speed of discharging. So in case of one NMOS, we have two NMOS now. If we have two NMOS, so in saturation region, we will have two current source. If we have two current source, that means we will have more current. So more current will be coming out of this capacitor. Right? In saturation region, we will have two current source. That means more current will be coming out of this capacitor. That means it will discharge fastly. So the speed of discharging is increasing. Or what you can see, in case of NMOS, when it is in triode region, it will be replaced with the R1 value, right? This will be replaced with R1, this will be replaced with R1. So what will be the time constant? Time constant would be R1 by 2 into C. Your time constant is decreasing. That means speed of charging is increasing. Time constant means whatever time it takes to reach some value, right? Whatever the time it takes to let us assume what is 3 to time or 4 to time. In 4 to time, the capacitor completely discharges. Okay, so if it is taking 4 to time, that means it will take 2 into R1C time, and before it was taking 4 into R1C time, right? So the time taken to get discharge is less. That means your speed of discharging has increased. Okay, so tau would be equals to R1 by 2 into C for discharging. That means speed of discharging has increased. Okay, so these kind of questions can be asked. Okay, So this is the complete analysis of pulse input. Now we will see the most important one, that is the ramp input. We will increase the value from 0 to VDD. We will increase the value of V in from V in of 0 to VDD. We will not directly jump from V in 0 to VDD. We will increase it linearly from 0 to VTN to VDD by 2, from VDD by 2 to VDD minus VTP, and then to VDD. Okay, so just you just need to have a strong concentration for that. Okay, so we will start it in next video. Okay, thank you.